Okay, question number 1. In return for payment of 2,000 at the end of 4 years and 5,000 at the end of 10 years, an investor agrees to pay 2,000 early to make an additional payment at the end of 3 years. Find the amount of the additional payment if interest equal to 0.06. And my answer is 1593. Okay. Question number 5. Whereas the choice of a comparison date has no effect on the answer obtained with compound interest, the same cannot be said of simple interest. Find the amount to be paid at the end of 10 years, which is equivalent to 2 payments of 100 each. The first to be paid immediately and the second to be paid at the end of 5 years. Assume 5% simple interest is earned from the date each payment is made and use a comparison date of A. The end of 10 years, B. The end of 5 years. So the answer for the end of 10 years is 275, and the answer for the end of 15 years 260. Okay. Now is question number 8. The present value for two payment of 100 each to made at the end of n years and 2n years is 100. If interest equal to 0.08, find n. So this is the answer, and the final answer is n equal to 6.2527. Okay, question number 11. A deposit 10 today and another 30 in 5 years into a fund paying simple interest of 11% per year. B will make the same 2 deposit, but the 10 will be deposited n years from today and the 30 will be deposited to n years from today. B's deposit earn an annual effective rate of 9.15% at the end of 10 years. The accumulated value of B's deposit equals the accumulated value of A's deposits. Calculate n. So this is my answer, and my final answer is 2.33. Now, question number 18. The sum of the accumulated value of 1 at the end of 3 years at a certain effective rate of interest and the present value of 1 to be paid at the end of 3 years at an effective rate of discount numerically equal to I is 2.0096. Find the rate I. So this is my answer, and my final answer is 4%. Question number 20. Assume a sum of $1,000 is invested for the month of July and August at 6% simple interest. Find the amount of interest earned. A. Assuming is the exact simple interest. The answer is 101.92 cents. B. Assuming ordinary simple interest. The answer is $100. C. Assuming the banker's rule. The answer is 103.33. Okay, question 28. Find the accumulated value of 100 at the end of 2 years. A. If the nominal annual rate of interest is 6% convertible quarterly. So K is 100, interest I is 0.06, M is 4. So A2 equal to 100 times 1 plus 0.06 over 4 the power of 8. The answer is 112.65. B. If the nominal annual rate of discount is 6% convertible 1 every 4 years, A2 is equal to 100 times 1 minus 0.06 over 1.4, 1 over 4, the power of 1 over 4 times negative 1 over 4 times 2. So the answer is 114.71. 29. Given that I is 0.1844144 and D equal to 0.1802608, find M. So this is the equation, and the answer is 8. Okay, now question 35. Any investment is made for 1 year in fund whose accumulation function is second degree polynomial. The nominal rate of interest earned during the first half of the year is 5% convertible semi-annually. The effective rate of interest earned for the entire year is 7%. Find 8, 5. Second degree polynomial function. AT equal to AT squared plus BT plus C. So this is the answer, and the final question, and the final answer is delta 5. For delta 5 is 14 over 205. Question number 40. In Fund X, money accumulates at force of interest. This one. In Fund Y, money accumulates at an annual effective interest rate. An amount of 1 is invested in each fund for 20 years. The value of Fund X at the end of 20 years is equal to the value of Fund Y at the end of 20 years. Calculate the value of Fund Y at the end of 1.5 years. Okay, my final answer is 1.3499. Okay, question number 47. Method A assumes simple interest over final fractional periods, while method B assumes simple discount over final fractional period. The annual effective rate of interest is 20%. Find the ratio of the present value of a payment to be made in 1.5 years computed under method A to that computed under method B. So this is my answer, and my final answer is 120 over 21. Over 1 to 1.